Hi everyone, this is the help video for Unit 7, Statistics and Probability. As always, please use this help video to help you prepare for the test. And as always, if you have any questions, you can reach out to any of your teachers. There is also a notes deck available for you where I have written out all the notes from this and also from live class, so you can use that to review for your test as well. So we're going to go over all the concepts that we discussed in our unit 7. The first one is best measure of center. And when we talk about measure of center, we talk about an outlier. That was a new vocab word for us this unit. An outlier is a point that does not quite fit in with the rest of the data. So we have a line plot here. As you can see, the data is clustered right here. And then we have a number that is pretty significantly outside of the cluster of our data. That is an outlier. So again, an outlier is a number that doesn't quite fit in with the rest of the data. It's important to be able to recognize outliers and how they impact our graphs. So we also talked about skew. Skew is when a graph is not balanced, where it's shifted either to the right or to the left, and that is caused by an outlier in the data. So that number that doesn't quite fit in can really change the way our graph looks. So when we have an outlier present, we need to look at what is the best measure of center and what is the best measure of variability. So if an outlier is present, we want to use the median as our best measure of center, and we would use the interquartile range as the best measure of variation. In this data set, there is an outlier present, 35. So in this case, we would be using the median and the interquartile range as the best measure of center and the best measure of variation. Now, if no outliers are present in our data, so we can look at our second data set, that data is balanced. There is nothing that is way out of line. Everything is pretty much clustered around the same couple of numbers. If no outliers are present, we still can find the best measure of center. In this case, it would be the mean of the data. And the best measure of variation would be the range. And so again, using this information to solve a question on your test, this is particularly helpful for question number 1 on your unit test. Again, outlier is present, we would want to use a mean or the IQR. If there is no outlier present, we would want to use the mean or the range. Next, we can calculate the best measure of center. So we've already talked about a few of these words on the last slide. Now we're going to work on solving them. We've got median, mean, and range. So let's go over all 3 of those. None of these should be new. You did learn these last year, but just a refresher, the median is the middle of the data when the data set is ordered from smallest to largest. So this data set, 1, 4, 4, 6, 7, 8, 8, 9, 10, it is in order. So we're going to find the median or the middle of the data set. The way I like to do it is I just cross off evenly from both sides, going from smallest to largest and moving towards the center. And this data set that leaves us with one number in the middle, and that number is 7. So by calculating the median of this data set, we were able to find that the median of this data set is 7. The next measure of center we can discuss is mean. Mean is also known as the average. So in order to calculate the average, you are going to add up all of the values and then you divide by the number of values in the data set. So I'm gonna use my calculator just to make it go quickly. 10 plus 9 plus 8 plus 8 plus 7 plus 6 plus 4 plus 4 plus 1. So when I add all of these numbers up, I get 57. And now I'm going to divide by the number of values in my data set. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 57 divided by 9 gives me 6.3 repeating. So as you can see, even with the same data set, your measure of center, depending on if you're using the median or the mean, is different. Nothing in our data set changed. We use the exact same one. But when we use the mean, our average was 6.3 repeating. When we use the median, our average or our median there was 7. So just an example of how, depending on your data set, your measure of center can be different, whether or not you're using median or mean. Our last measure that we're going to review here is range. This is for variation. And range, you're simply going to take the largest value of your data set, in this case 10, and subtract it by the smallest, in this case 1, and you're going to subtract. So the range of this data set is 9. Range is just describing the spread of the data. How many data points does it cover? We can also talk about box plots. So when we're reading a box plot, it's important that we look at the, oops, let me go back. It's important that we look at where each part of our box plot lines up with the number line at the bottom. It's called a box and whisker plot because there is a centralized box, which holds 50% of our data, and then 25% of our data is in one whisker, 25% of our data is in the other whisker. There are other important aspects of a box and whisker plot. We have the minimum, which is the smallest number in our data set, the maximum, which is the biggest number in our data set, the median, which, just like we already discussed, is the middle of the data set. Now, it's important the middle of your data set is the number that falls in the middle of the data set. That doesn't always mean it's right in the middle visually. So that's an important distinction. It's numerically the middle of the data set, doesn't always visually look like the middle of the data set. Then the outside of our box, those are our quartiles. So when we were in class, we described these as the medians of the upper and lower set of data. Q1 and Q3, we can calculate the interquartile range by subtracting the Q3 minus the Q1. That is your IQR. So this information is helpful for questions 4 and 6. You're going to be asked to analyze a box plot, and you're going to be asked to analyze a dot plot and calculate mean and median. So you can use this page again for questions 4 and 6 on your test. Next, we're going to talk about sample and populations. There is a graphic here that we can use. And in this graphic, we have a large population circle that is full of different bodies and different colors. And then we can see that a few of those people are pulled for that little sample bubble. So what does that tell us about a population versus a sample? Well, a population is large and a sample is small, but the sample is made up of people from that population. The goal of using a sample when discussing populations is to get information about the sample that would help you get insight on a population. So often when we're talking about populations, we're talking about really large numbers, numbers that would be very difficult to poll or survey. So we would use a sample to give us information about the population. So here is an example question that I am going to solve on the board with you. A pizza shop makes 60 pizzas in an hour. Of those 60 pizzas, 12 of the pizzas were messed up and thrown away. If 500 pizzas are made in a day, how many pizzas can the shop expect to be messed up by the end of the day? Create a proportion to solve. So we can see a sample here. They took a sample of 60 pizzas, and out of those 60 pizzas, 12 of them were messed up. So this shop wants to figure out, well, if we make 500 pizzas in a day, how many of those are getting messed up and going into the trash? So again, finding information from the sample that could give us information and insight about the population. In this case, our sample is what happens within 60 pizzas in that 1 hour. And then our population, the large data that we're looking at, is how many pizzas are they throwing out in a day. So I set up my proportion here, again, my 12 out of 60. And then in order to figure out how many pizzas were messed up, my numerator is my unknown value. My denominator is the number of pizzas made in that day. I am going to use cross multiplication to solve. So multiplying across, I have 500 times 12, and I have 60 times x. And as a reminder, with all of these questions, you are able to use that calculator. I do have it linked for you at the beginning of the test, because really the goal of this test is to make sure you understand the setup and the formulas. You can let the calculator help you with some of the operations. So 500 times 12 is 6,000. So we have 6,000 equals 60x. Now, if you remember, when we're talking about solving equations like this, the goal is isolating the variable. So we need to get rid of anything that is attached to our variable. In this case, it's being multiplied by 60, so we would divide both sides by 60. And then if we take 6,000 and divide by 60, we get 100. So going back to the original question, if the pizza shop messes up 12 pizzas out of 60, then we can anticipate that they would mess up about 100 pizzas out of 500. So again, using populations and samples, they're not always exact and it's not always perfect. However, we can use the information for us to gain insight about what could happen in a population. So setting up a proportion and reading a word problem like this is particularly helpful for question number 3 on your unit test. So if you're struggling with question number 3, you can review this page again. Next, we have circle graphs and calculating internal angles. So we're going to discuss a few different things about circle graphs, and then we'll solve a practice problem. So the first important aspect of a circle graph is that any circle is made up of 360 degrees. So with this particular standard in question, if we're trying to calculate the internal angle of a particular sector of our circle graph, we know that it has to be less than 360 degrees because 360 degrees is the entire circle. So that's just some information that we can use to check our work. Circle graphs are presented as percentages. So when we are calculating these internal angles, we are going to be given a word problem or a graphic where the sector is given to you in a percentage form. We have to convert in order to find what the internal angle is. So in order to do that, there are 2 steps, and we're going to follow them with this example problem here. Multiply each percentage by 360 degrees in order to find the internal angle of each section. So let's start with comedy. Comedy is 37%. We are going to convert 37% to a decimal. In order to convert to a decimal, you can either divide by 100, or you can move that decimal point 2 times. It does the same thing. Now that we've converted that to a decimal, we have 0.37. We are going to multiply that by 360. So we have 360, I'm using my calculator for this, times 0.37, and that gives the angle of 133.2 degrees. Now I'm going to do the same for one more. I'm going to look at the horror category. So in this case, my percentage is 20%. Going to convert that to a decimal, 0.2. After your percentage is converted to a decimal, multiply by 360. Again, you're always going to multiply these by 360 because that is the number of degrees in your circle graph. So 0.2 times 360 is 72. So for comedy, we calculated that that comedy sector, which is 37%, has an internal angle of 133.2 degrees. For horror, which made up of 20% of our data, we calculated that that had an internal angle of 72 degrees. So again, when talking about circle graphs, you've got 2 steps. Convert your percent to a decimal, multiply by 360. That's how you can find the internal angle. And this page is particularly helpful for question number 4 on your unit test. Next, we can talk about the best graph to use. So in this unit, we did talk about multiple types of graphical representations of data. So we're going to review a few and some keywords that stick out when talking about any of them. The first one is your bar chart. So the bar chart is a pretty safe choice. It's best for comparing categories of smaller data sets. You can also use a double bar graph if you are comparing more than one set of data. A histogram shows your data in ranges, so it's not great for very specific data. It's great for large sets of data. So you're not going to be able to read in a histogram specific pieces of data. You are going to get ranges of your data. Another distinction between bar chart and histogram, even though they look similar, a bar chart is going to have all of the bars separated. With a histogram, all of those bars are going to be touching. So that is a way that you could see the difference between histogram and bar chart. Next, we have a line chart, sometimes called a line graph. When you use a line chart or a line graph, that is comparing data over a specific time period. So that could be weeks, that could be days, that could be hours or years. The biggest thing to note is that it is over time. So whenever your data set is discussing time, the line chart or line graph would be the best graph to use. Next, we've got pie chart, also known as the circle graph. This is a proportional relationship out of 100%, just like we discussed on that last slide. Your data is split into categories, and you're going to look for words like proportion or percent. So those keywords like proportion and percent will really help you identify whether or not you should use a circle graph. It's also important to note that you would not have a ton of categories when talking about a pie chart or a circle graph. Usually those circle graphs are limited to about 7 categories or less. So you're just comparing a few different sets of data out of 100%. We also have stem and leaf plots, which break up your number by the tens and the ones place. This is not good for very large sets of data just because it is a lot of work breaking up every single number within a data set. And then we have a box plot. A box plot is that visual representation that shows your minimum, your maximum, your median, and it also is great for showing skew and outlier. So these are some graphs and the best time to use them. You can use the information on this page to help you with question number 5. Next, we talk about likelihood and sample spaces. So when discussing likelihood, that is a range, and that range falls from 0 to 1. As you can see on this graphic, it is a spectrum. So 0 is impossible. If something is impossible to occur, it could never happen. So that's the beginning of our likelihood scale. Is 0. 0 can also be represented as 0%, so a 0% chance of something happening. On the other side of that scale is 1, which can be represented by 100%. If something has a likelihood of 1 or 100%, it is certain to happen. So there is no doubt that it will happen. It will always, always occur. Within that 0 to 1, there is a range of numbers and percentages. So they do have it broken down here from fraction, decimal, and percent form. The closer you are to 0, the less likely something can happen. The closer you are to 1, the more likely something is to happen. And right in the middle would be equally as likely or as unlikely. An example of that would be flipping a coin. When you flip a coin, you have a 50-50 chance of landing on heads or tails. That is an equally as likely to happen scenario. So that's just a review of your likelihood. Again, if it cannot happen, then it is impossible. If it has a likelihood of 1 or 100%, it will absolutely happen. Another thing that we discussed in this lesson was sample spaces. So sample spaces are all of the possible outcomes in a given situation. The list of outcomes is the sample space. So there is an example on the board here where you can see this person is choosing between 3 different shirts, a blue shirt, a purple shirt, and a red shirt. They are picking two different bottoms, jeans or shorts. They have two different types of shoes, and there's 12 possible outfits. Now, in order for them to figure out all of those options, they want to create a sample space. And that sample space is a gathering of all possible combinations. So for blue shirt, they could possibly pick the jeans or the shorts. And then from there, they've got two types of shoes. And so that leads them to 12 different outcomes to list in their sample space. And you see a lot of repetitiveness, but they are all different, even though you can see the same thing, the same like B over and over or the S over and over. You can see that all the combinations are different because those are all the possible outcomes. You would not have the same outcome more than once. So in this case, your sample space is made up of these 12 outcomes because there are 12 different outfits that can be made with these situations. This page is particularly helpful for questions 7 and 10 on your unit test. And finally, we have probability. Probability was the last lesson that we covered in this unit, and there were two types of probabilities that we discussed. The first one is theoretical probability, also known as simple probability. And when we talk about theoretical probability, is what we expect to happen. So theoretical probability, no experiment has been conducted. It's just mathematically what should happen based on the situation. We can compare that to experimental probability. Experimental probability is what actually occurs in a given experiment. So these two numbers will not always be the same. Sometimes they might work out to be the same. But it's important to recognize that theoretical is what should happen, just based on mathematically what are the odds. Experimental is what actually does happen. We have two different formulas, but these formulas are very simple and very similar. So with theoretical probability, we're going to look at the favorable outcomes. So what is the question asking us for over the total possible outcomes? So we can go ahead and find the theoretical probability of this given situation. What is the theoretical probability of choosing a green marble? So in this case, green marble is our favorable outcome. So how many of these marbles are green? 1, 2, 3, 4, 5, 6. So 6 is going to be our numerator. Again, looking at that formula, the favorable outcomes. Because they're asking for green marbles, 6 of these marbles are green. And then the denominator is the total possible outcome. So what's the total count of this marble bin? So we already have 6 green, but we also have 1, 2, 3, 4 more marbles. So in total, there are 10 possible marbles to choose from. So we can simplify this as 6 over 10 can be simplified to 60% or 0.6. That is the theoretical probability of choosing a green marble. Now we can compare that to an experiment that was run. So in this situation, there were 50 trials in the experiment that were run. So if someone was picking a marble 50 different times, they would replace it, they would pick another one. Every time that they ran that trial, out of those 50 times, 28 times in our numerator, so the number of times the event occurred, was 28 times out of 50. So 28 out of 50 does give us a percentage of 56%. So we can use this graphic to compare, given the same scenario, they both have the same marbles, and the same number of marbles and the same number of green marbles. Our theoretical probability, we expected that to occur 60%. When an experiment was run, it only occurred 56% of the time. So you can see that the numbers are close, but there is sometimes a discrepancy between the theoretical and the experimental probability. You can use this page for help on questions 8 and 9. So this is the end of our review. At this point, we have covered everything that will be on your unit test. As always, if you have any questions or if you need anything, feel free to reach out to any of your teachers. There is a direct link to the unit test in your gradebook, and the notes for this unit test will be linked as well. Thank you for watching.